Alright, Mr. Stailey, in this video I'm going to be explaining z-scores and the standard normal curve. I developed a example to use for explaining the z-scores. It is important to understand that the mean is very important because we are comparing the z-scores to the mean for the scores of the set. I'm going to use test scores in this. So the scores that I came up with include 75, 77, 81, 82, 83, 85 and 85, 90, 91, okay, 91, and then 95. Can you still see that?
Mm-hmm.
Okay. Alright, now for each of these, you find their z-score by first finding, by putting them all into a list and finding the standard deviation. And to do that, you go in and find vars 1, and then just choose the list that you put it in, and then you go down to the little symbol that looks like this, and then for the whole list, and then that gives you your standard deviation. And after you find the standard deviation, then you have to put it into the formula, and I just put in, I just used this L1 minus, the average for this was 84 for this set of scores, and the standard deviation was 6.24. And you type that in, and it will give you, I put it in list 2, and then it went down in list 2 and gave me each of the z-scores for each one of the test scores. So the z-scores came out to negative 1.4, negative 1.1, negative 0.48. Again, this mean is 84. So 0.32, that's why it's getting closer and closer to 0. And then negative 0.16, and then since it's just 1 away from the mean, this would be 0.16. I need another 85 in there, so just know that there's another 0.16 right there. And then 90 is 0.96. 1.1, and 95 is 1.67 or 76, and those are the respective z-scores for these 10 sets of test scores. Now that we have found that, now that we found the z-scores for each one, then we apply them to the normal standard curve. Now, using the normal standard curve, it's very important to understand, as you have stated before, that under the bell-shaped curve, the area is 1. And I thought it was interesting when I was watching some of your videos that as we put in CDF, negative 3 and 3, the value got closer and closer to 1, but it will never hit 1 because the x-axis or the z-axis is an asymptote of the values, or of the graph. So as we put these in, we will use the normal standard curve to find out probabilities of what I'm going to use Jezebel because she doesn't get very good test values. So she's bad at math, as she is bad in other places, if you know what I mean. But anyway, we will use it to compare some of the z-scores, and my first example is the probability that Jezebel will get below an 85. So if we draw out the graph, it's going to look a little something like this. There's going to be 0, we'll call that negative 1, call that 1, we'll call that 2, we'll call that 2, and then out here is -3, -2, and out here is going to be -3. So we'll come down like this and inflect and come down, and we'll come down like this and inflect and come down. Not the best graph you've ever seen, but it serves its purpose. Now to get between an 80, we said below an 85. So the z-score of an 85 is 0.16. So that's going to be about right in here. Not exact, but you get the idea. So this will go from here, and it'll be everything on this side of the graph. Now to put this in your calculator, all you have to do is go to second distribute, and then you put in CDF, and then you put in the left and the left stopper and the right stopper. You like to use -10 for yours, so I'm just going to do -10 because it's an easy number to put in. It has to be less than 3 though, or it has to be less than -3, so -10 is my choice. And then you use as the right bound is what it's called, 0.16 is going to be your right bound, and then it gives us the probability that she will score below an 85. We know it's going to be greater than 50% because it's going to be over to the right a little bit, and the probability, after you put in your calculator and get out the number, the probability that she scores a 85 or lower is 56.4. Like I said, a little bit more than 50%. The second problem is dealing with intervals. What is the probability that Jezebel will get between a 75 and an 82? So a 75, the z-score for a 75 was -75 is -1.4, so that would be about right in here. And then we'll erase that. And then between an 82, the z-score for an 82 is -3.2, so that's about right in there. And so we are looking at the value of right in here. That's what we're looking for. And you put it in, and the left bound would be the z-score for -1.4, and the right bound would be the z-score -0.32. You put that in your calculator, and you get the probability of 29.4% would be the probability that she scores between a 75 and an 82 on her next test. The last problem is pretty self-explanatory. It's just in the reverse. What is the probability that she scores above a 90? So I saved this problem to do on camera, and all you would do would be find that the z-score of 90 is 0.96, which is probably going to be about right about here, maybe closer to 1, and then you look, and it is going to be the value of everything in that direction. And then you just go to second distribute, go down to normal CDF, and then you type in the left bound, which would be 0.96, comma, and it would be anything above 3. So I'm going to choose the number 10. And the probability, we get 0.1685. So we're going to round the 5 to the 8 to make it a 9. And so the probability that she scores above 90 equals 0.1685, which is also approximately 16.9% that she scores a 90 on her next test. Alright, Ms. Stailey, thank you very much for your time, and looking forward to seeing you in class.